Okay, so for 2D electric forces, they could ask, what is the net electrostatic force on the upper right charge of this square configuration? So common questions with 2 dimensions usually deals with either a square or an equilateral triangle. So I want to go over these 2 very common types. Anything's possible, but I want to show you like how to set these up, because a lot of times it deals with just understanding symmetry. So if I'm going to call this charge 1, charge 2, and charge 3, they're all positive in this case. So it's going to repel from this one. So that's going to be force 1. That'll be force 3. And this will be force 2. And let's say the distance is going to be L across all these, okay? Well, if it's L, then the diagonal, if you recall, is going to just be L root 2. That's just doing Pythagorean theorem. L squared plus L squared equals the diagonal squared, and you solve, you end up being L root 2 for that distance. So force 2 is going to end up equaling KQQ over L root 2 squared. So that'll be KQ squared over 2L squared, and it's at a 45-degree angle. So it's at 45 degrees above the horizontal. Force 1 is KQQ over L squared, and that's in the X direction. Force 3 is KQQ over L squared, it's in the Y direction. What you have to realize is, since force 1 and force 3 have the same magnitude, when I combine them, they're going to be in the same direction as force 2. Again, if I had something that was, say, like 5 newtons and 5 newtons, then I know the result of adding them together would be this vector I just drew, which is going to be at a 45-degree angle, which is basically 5 root 2. Very similar to L, and L root 2. So that's what you have to realize here. So in this case, I know the sum of the forces. And again, when I say sum of the forces, remember, this is a vector. We're dealing with 2 dimensions here. That means if I take force 1 and force 3 and combine them, it's going to end up equaling KQ squared over L squared root 2 at a 45-degree angle. Well, if that's at the same 45-degree angle now as force 2, then I can just add these 2 together to get the total net force. So I'm going to add these 2 together because they're going in the same direction. So it's going to be KQ squared over L squared, and I'm factoring out the 1/2 and the square root of 2. So plug that into a calculator, and the final answer here is going to be about 1.91. Come on, let me write. K Q squared over L squared. So make sure to go back and watch that again. There's a lot of information dealing with actual vectors that aren't just X and Y. So symmetry plays a factor. Just like for an equilateral triangle, if they ask what's the force in this bottom charge, okay, again, I'll call this charge 1 and charge 2. It's going to repel and repel in this case. Well, guess what? They repel in such a way that if we think about the angles here, we have 60, 60, 60. We bisect, that's going to be 30 and 30. And if I call that, let's see, force 2, because it repels in force 1, well, I know that force 1 is going to equal force 2, at least the magnitude, not the direction, is going to be K, and we'll call it the distance again, L, L, L. So it'll be K Q squared over L squared. Well, let's talk about now the directions here to find the sum of the forces. So what's the net force if I was to add them? Well, force 2 is going down and to the left. Is going down and to the left. Force 1 is going down and to the right. Well, guess what? The left and the right components are going to cancel. So it's going to be down and down. So that means that the sum of the forces in the y direction is your net force is going to be going down, KQ squared over L squared times the, well, let's see, that's adjacent to the hypotenuse. So that would be cosine of 30 degrees. And there's 2 of them that are doing that. Cosine of 30 is root 3 over 2. So the final answer would be negative, let's see, root 3 KQ squared over L squared, or you would say root 3 KQ squared over L squared in the negative Y direction. So there you go with 2 examples to make sure you understand the concept of symmetry and finding forces in 2 dimensions.